Hello. Okay, we're gonna look at the pseudocode for linear regression implementation today before we dive into the code. And we're doing this because of two main reasons. One, it helps us have a framework so that whenever we do code, we are not confused. And then number two, I want you to look at the pseudocode. And then try to implement it yourself. If you get stuck, that's okay, right? Because I'm gonna do it in the next video, but I do want you to give it a try. Okay, so our goal is to find the best fit line, which we know is our wx plus b. Okay, now w is the slope of the line and b is the y-intercept where the line starts, our bias. So now let's break the problem into simple steps, and I'm going to use different colors here just so that it's easier to follow. So one, we are defining the linear regression model. Okay, and I'm gonna choose, that's F. Okay, hypothesis, or our prediction formula is HWX plus WX plus B, which we already know. Now define the cost function. Our MSE means squared error, and which was I think this was the pen I was using, so we already know this. Let me actually write it better because it's a pseudocode, so I'm gonna write it in a way that'll be easy to implement. Okay, and summation HWXI minus, and then that's underscore. I'm just writing out the underscore, so in case you want to type it out, you have it as a reference. Now what we're doing next is computing the gradient slope using partial derivatives. And we've looked at this already, right? So we know that dj by dw, my favorite brother calls me DJ. Summation HWXI minus yi times our xi, and then we have our dj by db, which is 1 by m times summation hw, which is our h underscore w x underscore I minus y underscore I. Okay, and then next what we're doing is performing gradient descent. And see how everything's just coming together very nicely? Aren't you glad we learned all of that? Our alpha learning rate times dj by dw, and then b minus alpha times dj by db, and then we repeat the above steps until cost is minimized. And we know how the cost is minimized when it's converging to 0. Okay, 5. Now we train the model. Okay, I don't know why I got so excited about that. Okay, so initialize our W and B to some random value like 0 or some small random value. Okay. Set learning rate. And we talked about how we want the learning rate to be not too big or not too small. So maybe like can start out with 0.05. Actually no, I want you to start with 0.01 and then go from there, but feel free to adjust. And then loop for a number of iterations, and here I want you to compute predictions, which is our HWX, calculate cost, our cost function, compute gradients, our dj by dw and dj by db, and then update w and b using gradient descent. And then finally what I want you to do is make predictions. Okay. And here it's basically given a new x value, and then I want you, like this is uppercase X, right? I want you to give multiple values. Compute y pred equals to wx plus b, and then I want you to evaluate the model. So I want you to plot cost function versus iterations to check convergence. It's just something fun to do, okay? And then I want you to print final values of W and B. And then finally, I want you to compare predicted values with actual values, okay? Does that make sense? So basically what we're doing is we are defining the model here, which is our hypothesis, and then next what we're doing is defining our cost function, and it's the mean squared error. It measures the difference between actual and predicted values, squares the difference to avoid negatives, and takes the average so that we get a single number. Just recapping what we've already discussed. And then here we are computing the gradient, and it's through the derivatives, and we've looked at the derivation of how we reached there. We enjoyed that math for partial derivatives, so it's helping us decide how fast something is changing, right? So this formula shows us the direction to move in order to reduce the cost, right? Now in this step 4, now that we have the gradient slope, we update W and B step by step, where alpha is the learning rate, and we repeat this process until the cost stops decreasing, right? We remember that we talked about the slopes. So we repeat it until the cost stops decreasing. Let me actually write here. repeat until cost stops decreasing. That might be clearer, right? Okay. And then what I want you to do here is train the model. So you compute the predictions, calculate cost function, compute gradients, update your W and B using gradient descent, and repeat until we reach the best bit line. And then here is the fun part where we get to make predictions. Once our model is trained, we can predict the new values using this formula right here. And then finally, I want you to evaluate the model. Does the cost function decrease over time? Does the learned W and B sort of make sense? I want you to analyze that, and I want you to see if the predictions are actually close to the actual values. And then you can do your mean squared error for this as well. So yes, congratulations, you just built linear regression from scratch. If you're able to follow these steps in the pseudocode and you get stuck, don't worry, we will work on it together in the next video. Good luck!